Hello my students, hope to be fine and healthy, also hope you have reviewed the last videos. Today we are going to study a new lesson which is general properties of waves. By the end of this lesson you will know what is meant by a wave, types of waves and wave equation. What a wave is. A wave may be thought of as a spread of disturbance. If you drop a stone into a pond, ripples spread across the surface. The tiny waters carry energy, as you can tell from the movements they cause at water's edge. But there is no flow of water across the pond. The wave effect is just the result of up and down motion in the water. So, waves not transfer matter, only transfer energy. This four meaning of waves. Waves divided into two types depending upon the direction of oscillation to direction of travel. We have two types of waves. First type is transverse wave, second type is longitudinal waves. Transverse wave. The direction of vibration is perpendicular to the direction of wave travel. This wave, same in case of water waves and electromagnetic waves. Transverse wave consisted of crests and trough. The distance from first crest to next crest called wavelength. Also the distance from first trough to second trough called wavelength. Electromagnetic waves, same light waves. Transverse waves can travel through vacuum or space, same light waves. Second type is longitudinal wave. The direction of vibration is parallel to the direction of wave travel. It consisted of compressions and rarefactions. Sound waves considered as longitudinal waves, so longitudinal waves need medium to travel through it. Longitudinal waves cannot travel through vacuum or space. Some terms and their meaning that helped us to understand waves. Crests and trough. The highest point on the wave called crests, the lowest point on a wave called trough. Amplitude. Amplitude defined as the maximum displacement from rest position. Phase. Two points that are moving in the same direction at the same speed and having same displacement from the rest. Wavelength, the shortest distance between 2 points on phase. Frequency, refer to number of complete waves produced in 1 second or number of oscillations produced in 1 second. Period, refer to time taken to produce one complete wave or time needed for one complete wave. Wave speed, mean distance traveled by the wave in 1 second, and its unit is meter per second. These terms are very important. After that, the symbol and units of these terms. Amplitude, its symbol is A and measured in meter in SI unit. Wavelength, its symbol is lambda and its unit is also meter. Frequency, its symbol is F and its unit is hertz or second minus 1. Period, its symbol is T capital and its unit is seconds. Wave speed V and its unit is meter per second. Parts of waves. This diagram called sinusoidal waves. This diagram can be used to indicate longitudinal waves and transverse waves. As we see, the distance from first crest to second crest called one wavelength, or distance between first trough and second trough also considered as one wavelength. Wavelengths mean the distance between two similar points of a wave. Amplitude refer to the maximum displacement the rest position. Wave equation. V equal F times lambda. The symbol V refers to speed of wave. The symbol F refers to frequency. The symbol lambda refers to wavelength. Speed measured in meter per second, frequency measured in hertz, and wavelength measured in meter. Wave equation indicates that inversely proportional between frequency and wavelength. As frequency increase, wavelength will decrease. As frequency increase, wavelength will decrease. So, wave indicate the relation between frequency and wavelengths. Now we will solve some questions related to wave equation. The speed of sound is 330 meters per second. If the wavelength of sound was 4 meters, what was the frequency of the sound? He wants to calculate the frequency of the sound. We will use wave equation to calculate this frequency because he gives us the speed of sound and its wavelength. The speed equal 330 and frequency unknown, lambda equal 4. So F equal 330 divided by 4 equal 82.5 Hertz. This for calculating of frequency. Relationship between T and F. T refers to period, F refers to frequency. Period equal 1 over frequency. We know that period refers to time needed for one complete oscillation, and the frequency refers to number of waves in 1 second. Period equal 1 over frequency. It means if number of waves passes in 1 second equal 5, so time equal 1 over 5. If number of waves passes in 1 second equal 2, so period will equal seconds. This for relationship between T and F. Now we are going to solve these questions that related to all lessons. The wave in the figure traveling across water, or the wave transverse or longitudinal? What is the wavelength of the wave? What is the amplitude of the wave? What is the period and frequency? First question, are the wave is transverse or longitudinal? In the question he told us that this wave traveling across water, and we know that water is transverse wave, so this wave is transverse wave. Second question, what is the wavelength of the waves? Wavelength defined as the distance between two similar points on a wave. So in this case, wavelength equal 7 times 2. He give us only the half distance between the distance between half of wave. So wavelength equal 7 times 2, which equal 14. Third question, what is the amplitude of the wave? We know that amplitude defined as the maximum displacement from the rest position. From this diagrams, we see that maximum displacement equal 18, so amplitude equal 18 centimeters. What is the period and frequency? Period defined as time needed for one complete oscillation. One complete oscillation means from trough to trough or from crest to crest. By using this diagram, the period equal 3 seconds. So frequency equal 1 over period equal 1 over 3, which equal 0.33 Hertz. This for our lesson. This is the end of our lesson today. Try to solve your homework that uploaded on Moodle.